All right, let's get right into it. Today, we are breaking down one of the biggest game changers in modern software, Docker. We're going to find out how this one tool finally put an end to a developer's most infamous excuse.
Oh yeah, you know the one. The 6 most frustrating words in all of software development. If you've ever worked in tech, you've either said this, you've heard this, or you've probably screamed it into a pillow at 2 a.m. It's the classic sign that something has gone horribly wrong between a developer's laptop and the actual server where the code is supposed to be, working.
For a really long time, this wasn't just some flimsy excuse. It was a daily, painful reality. So to really get why Docker is such a big deal, we have to go back and understand the absolute nightmare it was built to solve.
Developers had a name for it, the Matrix from hell. And honestly, that's not even an exaggeration. For decades, deploying software felt like trying to solve an impossible puzzle in the dark. You'd write this beautiful, perfect code on your computer, but getting it to run literally anywhere else, a testing server, a live production server, even your coworker's laptop, was a total minefield.
So, what could actually go wrong? Well, how much time do you have? The server might be running a slightly different version of its operating system. Or it could have an older version of some critical library your code depends on. Maybe your app needs Python 3.9, but the server is stuck on 3.7. Every single one of these tiny differences was a ticking time bomb, just waiting to bring your entire application crashing down. So, how did we finally escape this nightmare? Well, the solution was absolutely brilliant, and it actually came from a completely different industry. It's all about creating a standard, predictable container for our code. The whole idea was inspired by global shipping. Just think about a port before the 1950s. It was total chaos. You had workers handling every single item differently. Barrels, sacks, crates, you name it. It was painfully slow and super inefficient. And then, the steel shipping container came along. Suddenly, it didn't matter what was inside. Was it bananas or car parts? Who cares? A crane just had to move one standard-sized box. This simple idea completely revolutionized global trade. Docker applied that exact same logic to software. A Docker container is that standard, sealed box. It bundles up your application, along with all of its libraries, its dependencies, its configurations, the whole shebang. You package it up once, and then you can ship that container absolutely anywhere, from your laptop to the cloud, and it is guaranteed to run exactly the same way, every single time. Okay, so this is where a lot of people get a little bit confused. They hear sealed environment and they immediately think of something that's actually been around for a while. Let's clear that up right now.
I hear this all the time. So wait, isn't this just a virtual machine, but like a little quicker? And the answer to that is a hard no. It's not just a little different. The entire approach is fundamentally different. And this analogy just illustrates it perfectly. A virtual machine, or a VM, is like building an entire separate house for every single one of your applications. It's got its own foundation, its own plumbing, its own electrical grid, a full copy of the entire operating system. It is incredibly heavy and wasteful. Docker, on the other hand, is like an apartment building. Each application gets its own private secure room, that's the container, but they all share the building's core infrastructure, the foundation and the plumbing. In the software world, that means they share the host machine's operating system kernel. And what does that efficiency look like in the real world? Well, a typical virtual machine can easily be several gigabytes in size. A Docker container? It's often just a few megabytes. We are talking orders of magnitude smaller. This isn't just a small improvement, it's a completely game-changing reduction in size. And that tiny size translates directly into insane speed. A virtual machine can take minutes to boot up because it has to start an entire operating system from scratch. A Docker container, since it's just starting a single process, not a whole OS, can launch in milliseconds. It is practically instantaneous.
Okay, so we get why Docker is so great, but how does it, actually work? Don't worry, there's another simple analogy that makes it all just click into place. And that's the beautiful thing about Docker. You really don't need to be some kind of systems wizard to use it. The entire workflow from start to finish really just boils down to 3 core ideas.
So here they are, the 3 Musketeers of Docker: the Dockerfile, the image, and the container. Just think of it as a simple process. You start with a recipe, you use it to cook a meal, and then you pack that meal in a lunchbox to take with you anywhere you want. So first up is the Dockerfile. And this is nothing scary, it's just a plain text file.
It is the recipe for your application's entire environment. You just write simple, line-by-line instructions like, okay, start with a base version of Linux, then install Python, then copy my application's code right into the box. That's it.
Now, when you build that Dockerfile, you create something called an image. So think of this as the finished meal, the result of perfectly following your recipe. It's a static, read-only snapshot of your application and all its dependencies, frozen in time and, this is key, completely unchangeable. And finally, we get to the container. When you run an image, it springs to life as a container. This is like taking that meal you cooked and packing it into a lunchbox so you can actually use it. It's the live running instance of your application. You can start it, stop it, delete it, and the original image remains totally untouched, ready to be used to create another new lunchbox tomorrow.
So when you put those three concepts together, the Dockerfile, the image, and the container, you get this incredibly streamlined workflow that pretty much all modern software companies use today.
It all boils down to this powerful three-word mantra: build, ship, run. It's that simple. First, you build your Dockerfile into a portable image. Then, you ship that image up to a central storage location. And finally, you can run that image as a container on any server anywhere in the world, as long as it has Docker installed.
So that ship step, it involves a central place called a registry. And honestly, the best way to think of a registry is like an app store, but for server code. Docker Hub is the most famous one. It's where you can store your own private images, or you can pull down thousands of pre-built ones for things like databases or web servers.
So what's the big takeaway here? What's the crucial point of all of this? It's that Docker creates a clean separation between your application and the machine it runs on. Your developers can focus only on the code inside the container, and your operations team can focus on just keeping the machines running without ever having to worry about what's inside each individual box.
And that really brings us to our final thought. In today's world, the consistency and reliability you get from containers, well, they aren't a luxury anymore. They are the standard. And it really makes you think, right? Are you actually building a predictable system for deploying your software, or are you just crossing your fingers and hoping for the best?